board. And I figured out what the problem was. Apparently, it was like something with the system that went down because the same thing happened with the lecture for so that's why.
Dr. Chen,
so
Dr. Lyons.
hopefully this time will be very quick and I can just like put it up there.
Absolutely.
So let's start. I was talking to I know there's a lot more people on here now, but I said that we first go over the questions from last week that we basically didn't understand at that time, and then after that we'll go over the membrane potential, that part of the PowerPoint, the like that people don't understand is, and make sure that we have like a good understanding of it. And then after that we'd go over the I can't say it, but augmentary system. Integumentary system, yes. Yeah. And go over that PowerPoint. And then if we have time left over that, then we will go into like just grazing over basically the basic of the neuro system, whether it be physiology or not.
Especially because whatever we go through tomorrow in class is like the last of what will possibly be on the test, right?
Yeah. So and then I think she's gonna do a question on Saturday too. She mentioned she don't know the time yet, but she's gonna do a review question on Saturday. That should be very helpful. We can ask all the questions we need to ask on Saturday.
Do you think that we'll get to the head stuff? I can't think right now. The
nervous system.
Yeah, the nervous system.
That's
like, do you think we'll get to that yet?
We can start, but I don't think we're gonna like do anything too crazy.
Because we still have the whole cell cycle, that PowerPoint that we didn't even go over yet.
Yeah, that's what I'm wondering. Are we going through that?
I don't think we are.
Because last week we finished the PowerPoint that we started the first class, so I think this week is gonna start the nervous system one too. Yeah, and then Dr. Berryhill or Chang, like there's supposed to be like a whole, because like they added the integumentary system like last minute, because at first it was supposed to be like this little thing for anatomy, but she didn't go over that. Like she literally added the integumentary system like 9 o'clock that morning.
Yeah, so
I think she said we're doing anatomy for nervous system tomorrow.
Okay.
Yeah, I think that they're going to move on from that, trying to get away from the membrane potential and try to go to the next thing, because they want to do neuro questions. They want to get that done because they want more than one thing on the test. So they're going to I'm pretty sure they're going to try to rush through anatomy.
Yeah, it's going to be like really like squeezed in. Like, I don't know. I'm just nervous. Like I'm not going to have enough time to actually like retain the information like the way I want to before the test. So it's kind of like unfair to us because they're behind. So
speaking of, do we have to go to class tomorrow? I'm sorry, I know I'm out of the question, but the fact that I don't see a new schedule, I was wondering if you keep, switch going back, because she mentioned
there's like a finalize of what's Monday and what's Friday. I mean, there should be a final. I don't know because I'm only online, but I'm also confused because on Zoom, the only Zoom link it says is tomorrow at 2. But I'm wondering if that's the same link we use to join at 1.
I think she said that she sent out another link. So I don't know if she's going to do that tonight or tomorrow morning. I can't remember the email exactly. But I think she said... Oh. I'm sorry? Got all busted down.
Yeah, I mean, I think she said the first 1 hour should be online for the other doctor who teach in Miami. So I was wondering, the fact that I'm supposed to go to class tomorrow in person, I was wondering if I can do it while I'm in school. I don't know. It's kind of confusing for me.
Yes, you can go to school. So she said that you can use the room to basically go into the class, which is what I'm going to do, because there's no possible way that I could like teleport there between two.
Yeah.
There's no way. So
that's what I'm going to do too. And I want to be in person so I can ask the question that I have, because this is the last day before first test. So like, I want to be there though. Well, let's go over.
Here in the message it said either today or early tomorrow she would send the Zoom link for the anatomy portion. So
So I think that we should start. So the question that I have starred for last week, the first one is name 3 functions of the sodium potassium ATP pump. So we're on or on the membrane potential worksheet on question 3, if any. So for that one, I got maintains ion gradient, essential for nerve and muscle stimulation, and allows for secondary active transport to happen. Did anyone get anything different or?
I feel like that's just like a weird question because when she talks about it, she's like, okay, you need to know, all you need to know is that it moves 3 sodium out, 2 potassium in, and then it breaks down in ATP in order to do that.
Yeah, that's exactly how I understand it too.
Yeah.
Because what she said, like sodium, I had it in my notes. Sodium is higher outside than inside. I think potassium is higher inside than outside. And then she just said we need to know sodium like three sodium out, and it's in for 2 potassium in. That's what I
the
have.
pump for every 3 sodium, 2 potassium get pumped in. I'm pretty sure.
Yeah, so that question is kind of like a concept question. So it's kind of just making you think about like what does this do for the body? Like what is the sense? Like what is basically like how is it important? Like why do we have to learn about it? So it maintains the ion gradient, which therefore allows for the secondary active transport to happen, because without that, then the gradient between high and low would be different. So the secondary, not to confuse anyone, secondary active transport is basically where because the gradient's so high, where sodium is so low inside the cell, and outside the cell, sodium is so high that it's able to transport another molecule with it through a pump system back into the cell through that kind of gradient, because it's so high outside the cell and so low inside the cell. So it just kind of like transports it because it can open that way. That's a little complicated. So I hope.
What was the second thing that you said after maintains ionic gradient? Like when you, in the very beginning, when you were listing the 3 things, what was the second thing that you said?
Essential for nerve and muscle stimulation.
Okay.
And then what was the third one? You said it helps in secondary transport?
Yeah, allows for secondary active transport to happen.
Okay, so I know you guys went over this last week, but I just want to make sure I have it right. For number 2, it says the opening of membrane channels can be controlled by gates. What factors cause these gates? Isn't it like a change in voltage? So like that happens through depolarization and then stimulation?
Yeah, so that's one of the 3 that could happen. That's for the membrane voltage one. But that's spot on. Okay. And then there's another one that's called the ligate gated channel, and it opens when a chemical adheres to the binding site. And then the third one is mechanical stretch gate, which it opens by a stretch.
I'm sorry, what sheet you working on? The membrane sheet?
Yeah, the membrane transport or membrane transport worksheet. I don't know exactly what it's called.
So where do you guys find this? Because the one that I have is like the membrane permeability. I don't know if it's the same thing.
It's the first worksheet from week 1. Yeah.
The first one?
So the first question is lipid bilayers are differentially permeable to different types of molecules. Do you see that question?
It's the same one. It's the same one.
Yeah.
Okay, I'm sorry, for number 2, you said mechanical stretch gate?
Yes. So it opens by a stretch.
I'm gonna go get I print mine out. Let me go get it.
For number 4 on this paper, isn't it edema? Like when you something swells?
So yeah. So for number 4, that was another one that we starred. I didn't want to move on before everyone got their answers written down and everything. But so the question, if the vessels of the brain have reduced the amount of plasma proteins, what effect would you expect this to have on the volume of extracellular fluid surrounding the brain neurons. So I put a decrease in plasma proteins means a decrease in osmotic pressure within the vessels, causing fluid to go into the extracellular fluid, which means cerebral edema. So yes, you're 100% correct.
You said decrease in plasma protein equals a decrease in
osmotic pressure within the vessels.
I just want to make sure I have a technical term.
So so it just means that so you know how we say like the osmotic pressure, it's kind of it means that the water will come out of the vessels because there's more concentration of whatever solute outside of the vessel. So they'll go into the extracellular fluid, or ECF, basically to try to dilute the solute or whatever solution, and then this will cause cerebral edema.
Okay, thank you.
No problem. Which actually, a side note, I've been getting addicted to these doctors talking about TV shows for the past couple days, which is probably not so good. But I've learned, like they talk about like so many different things that are really cool. And one of the things that our teacher said was mannitol or something like that, which is basically, a drug that basically it's like hypertonic to blood or something like that. But anyways, the doctor was talking about it, so it's really interesting to see how they would use it. I can't really remember, but like one was like Mama Dr. Jones, and there's a couple more, but they're really interesting. But that's just a side note. There was comments in the chat. See them?
I'm kind of confused on like question 4 because I feel like we didn't go over that really. Like I don't if I didn't look at her answer, like I wouldn't know how to answer it myself.
It was in the book. It was like I think it like under the clinical application. That's when it talks about it.
Yeah, 130.
Yeah, it was in the thingy because like when you go through her PowerPoint, she didn't talk about it, and then I think the first class like she mentioned it like this sounds really bad. Remember the picture of like the little African children? I think she mentioned it then, but it talks about it in the book.
She was like, "Oh, you don't really need to know or that we didn't need to know about that specifically."
Okay.
And she was also like, if I have to look at a picture to write a question, then that question won't be in she said that in lecture.
Right, because I was hoping that this wouldn't be like on the test because I'm like, I had no idea if I didn't read the book. And I know people from like third semester that I've been talking to, they never really use the book unless they reference something. So I was just worried. But I did hear that this is kind of like how she words her questions on the test. So.
Yeah, which is interesting. So like she used, just like you said, like the African children to basically, it's like histochondria, but really lack of plasma proteins or proteins in general causes edema. So you can just remember it like that. It will cause edema, which just means swelling and fluid surrounding in the extracellular fluid. So that's just so wherever it happens, if you just see a decrease in proteins or decrease in plasma proteins, just know that means edema. You can think of it like that, and you could probably write that in a flashcard if and honestly, that is a very it's a question that will probably be tested on us in the future. Like when we get into clinicals and stuff, we might have an instructor ask us like, what is one cause of edema? And that would be like a cause.
Is there an answer guide to this on Canvas? Okay.
Wait, but it says what effect would you expect it to have on the volume of fluid? So is edema the actual answer, or is there?
Well, I guess you could just say it would swell. So like the volume would increase.
Yeah, the volume would increase of fluid into the ECF or into the extracellular fluid. But that's just the word, it's edema, cerebral edema. So that's just like I just put that in there just to remind me that that's what it means, because sometimes I get confused with all the words and all the stuff.
If we have to write this question now, we'll get like brownie points for putting edema.
Maybe we'll get brownie points.
But do you think those questions in the test is gonna be that long? I mean, like the same way she word those questions in this question sheet. Do you think they're gonna be that long?
Yeah, I think so, only because she put it on Canvas like this, so I feel like that's what the test is kind of gonna resemble.
I'm like, she doesn't seem like the type that would do something like this for no
Exactly.
reason.
Yeah.
Yeah,
but like it's frustrating because the way she teaches is not very like how her questions are worded. She's always like fishing and like using crazy analogies. So when I saw this, I was like, what the?
I went on Rate My Professor, and like all of the people said, be careful how she words her questions because it can be like a little misleading. So just read them carefully. So I could see her, even though she talks about it and it seems so easy in class, I feel like she could put something hard like this on the test, and we kind of have to like depict out of the question what exactly she's asking.
Emily had the right idea because she was like, what would happen with the volume? So like you caught on.
Yeah, but even like let's say number 8, it's like right now it seems simple, but when it's something that's harder to actually understand, then I understand that it's like they all look really simple. I mean, they all look really similar. You just have to actually know what the words mean in order to like pick out the right answer.
That's why
I just. Sorry, you can go.
You can go.
I just honestly, for this first test, until you get used to how she words her questions, until and all that stuff, you gotta like reread, and no matter how tedious it is, honestly, it might save you. I mean, there's a couple times there was a question in here that I was like, I don't even know what this means, and then I had to reread it, and then I understood it. And then there was, obviously there's a question where I read it wrong, and I was like, oh no. And so then I went back and caught myself. But I think it's just so important, because some teachers, they do like to trip you up, and they like to be like, which of the following is not true, and like that kind of stuff. And I hate it. But it is.
Can you guys go over this question, the solution A and B? I don't know what number, because it come after the.
Yes, that was one that we starred.
That's 20.
Oh yeah. 20.
This two solution A and B are separated by semi-permeable membrane. That question.
So
because her answer is just from A to B. It's kind of confusing to me.
It's from B to A.
Yeah, from B to A. Yeah. Sorry.
So just like you were explaining, you can go.
I was gonna say, can we just do 20 and 21 again?
Yeah. So would you like to go in order, or do you just want to go? Because I know we have 15 that starts, 17 and 20, and then we can do 21 too.
It doesn't matter to me because I know you guys did, like, I just started doing this, but I know you guys did this last week, so you don't have to go through all the questions again.
Oh no, so last week we couldn't really answer some because we hadn't gone over it in class yet. So we starred some. There was like 15. We starred 17, 20, and then we can go over 21 too.
Okay.
So we can do 20 and 21 first. So 20, it says 2 solutions A and B are separated by a semi-permeable membrane, which only allows the passage of water. I phrased that as a question. Anyways, solution A contains 600 millimoles of sodium chloride, and solution B contains 250 millimoles of sodium chloride. In which direction will osmosis occur? So the answer is from B to A, but to break it down, you have to do the equation for to find out its basically which direction will it flow. So the first equation that you do is 600 times 2. And how you get 2 is because the dissociative ions, which is Na and Cl. So Na would be sodium and Cl would be
chloride.
Chloride. Or chloride. So that would how you get 2. Now it would be 600 times 2, which is 1200.
1200.
Exactly. So then you would do the next equation, which would be 250 times 2, because it's the same solute that we're talking about, which is sodium chloride. So
500.
Yes, it would be 500. So like I like to say that this is basically testing osmosis, which is the flow of water. And you're trying to see which direction will the water flow. So the water would flow to the more concentrated solute, which is 1200. So it wouldn't go to 500, so it would go to 1200. So osmosis would occur in the direction of the 600 millimoles of sodium chloride, which would be from B to A.
Oh, so basically that was the same one she was doing when she was drawing the thing, where the 300 was inside and then the 500 was outside. So that's basically the same example like in a word problem, right?
Yeah.
Yes.
And just like to remember, the water is always going to go to the highest solute. So like whichever is the highest number, like that's where water is going to go to.
Okay. Thank you.
Yeah, I like to say that water is an attention whore and wants to go and make more friends. So go to the population with the more friends. Wants to go there. Or water. Anyways, that's funny. I think. Anyways, so question 21 is the same question as number 19, except solution A contains 150 millimolar solution of sodium chloride and solution B contains 300 millimoles solution of glucose. In which direction does osmosis occur? So when you do the calculation, the sodium chloride would be 150 times 2 because sodium NaCl is 2 dissociative ions, and you get 300. So 300 is basically the
that would be isotonic.
Yeah, the middle point. So I don't know exactly how to say that, but it's where it's isotonic to the blood. So basically,
isotonic. There is no water movement.
Exactly. So then, then you have to do the next one. So solution B contains 300 millimoles of glucose. So you do take 300 times glucose, which is one dissociative ion, and you get 300. So they're equal to each other. So 300 and 300. So
that's osmotic.
Exactly. So that means that in this specific example, there is equal concentration of both solutions. There's no net diffusion.
No net diffusion.
Exactly. So they're just going to stay exactly.
Isotonic.
Where does it? I don't know if you guys know this, but like, they're on the notes. It says like if it's above 300, below 300. Do you remember like what chapter or which?
That's the tonicity side.
Oh, tonicity. Okay. Does that go in with this or no?
Yes. So
yes.
Anything below 300 would be hypotonic or hyposmotic because it's a solution.
It's like hypoosmotic.
Hypoosmotic. Yeah, I can't.
Yes, that's the word I cannot remember when she confused me with those words. Yes. So you mentioned something. I don't remember her name. I don't know her name actually. The black one. She said whenever the number is higher, this is where water will.
Yes.
If the solute is higher, if the solute
is whatever the number is high, this is where water will move, right?
Yeah. So if the solute is whichever solute has the highest concentration, is that how you say it?
Yeah.
Okay, that's where the water is going to flow.
Okay, thank you.
So does anyone have any questions about those two questions?
I had a question. How do you know when to use the word tonic or osmotic? Relating to tonic, hyposmotic. I know one has to do with like when it's relating to the cell, I think. And then she said it wasn't the solution because I know I wrote it down, but I still don't know what she meant.
I think it was like, because she was saying if the cell is in a cell will be in a hypertonic solution.
Yeah. So from what she just said, she's right. Emily's right.
It applies to like the solution itself. And then osmotic is just how the water is flowing. So I don't know.
So I think that so you're on the right track, I'm pretty sure. So when a cell is inside a solution, that solution would either be hypotonic, isotonic, or hypertonic. Now, when let's just say you're comparing two solutions. So in an earlier question, it says like cell B was osmotic to cell A. So when you're comparing two basically two osmotic pressures or something of the sort, two solutions, then it would be like hypersomatic, hyposomatic, that kind of stuff. Okay. I'm pretty sure when you're comparing, we'll probably ask that. When you're comparing two solutions, you use hyposomatic, hypersomatic, isosomatic of the sort. Yeah, so I'm pretty sure that.
Because I wrote down, she said tonicity can't be used in cell with cell or solution with solution.
Yeah. But it can be with cell to solution.
Yeah, tonicity is comparing a cell to a solution. So like if it's the ability of the surrounding solution to gain or lose water, that's tonicity. And then the solution to solution is osmotic, like osmotic.
Okay, wait. I'm gonna ask you. So you said tonicity is comparing the cell to solution. So like, you put a cell in a solution, right?
Yes.
And then the osmotic is just comparing what?
Like if you look at question 17 on the thing,
yes,
says
we
like
should probably go over that. Yeah.
It compares the cells, which are each in different solutions.
Oh, it's comparing A and B, right?
Yeah.
Yes.
Yeah. Got it.
So,
did we do 17 last time?
Yeah.
Yeah, we did, but we are gonna still go over 17 and 15 again because last time we didn't really have a good understanding of them anyways. So, it's a good, does anybody else have any questions?
Yeah, before we move on, can we just repeat it? So tonicity is comparing the cell to the solution, and the what was the other one?
Like osmolarity, I guess, is comparing cell to cell or solution to solution.
Okay, thank you.
What was the last one? I'm sorry. The first one was tonicity is comparing the cell to the solution. And then the second one was like, I'm sorry?
Osmolarity is comparing cell to cell.
To cell?
Yeah.
Lovely. Thank you.
Okay, so solution to solution. I'm just talking to myself. Okay, so does anyone else have any questions?
All right. You know what? Let's just move on. Let's just move on because I don't want to overthinking this. Because
what are you confused on? Because no, it still helps us to teach it.
Yes. I was gonna actually do the chart the same way she do it. I'm still thinking about the 20, how the water the osmosis occur from B to A, because the first one is 1200, right? And then the second one is 500. So I'm thinking about the chart. So the 500, is that the number that should be inside the beaker? The smaller number always inside the beaker, the way she do it, right?
What chart are you talking about?
Okay.
We're talking about 20. So basically I'm comparing it like this. So
20.
there's two, I don't know, I don't have two glasses around here, but like imagine I had two glasses in my hand and there was a semi-permeable, oh my gosh, I can't talk. Semi-permeable membrane in between them. Okay, and I have two solutions and I'm guessing there's water in it. Okay, so the water is going to flow in the direction of the 1200, that kind of in that direction. So osmosis will occur in the direction of the 1200, which is the 600 millimoles of sodium chloride. So if I have two glasses, the water is going to flow into into solution A. It's going to want to go and dilute that.
Oh,
the way it makes sense to me is like if it's saltier, it needs more water. Even though it doesn't have to be salt. It's like if it's saltier, it needs more water.
What I was thinking, I know she said water always occur where's the bigger number is. So I forget about like B. So it's make it. You know what? I got it now. Thank you. Let's move on, y'all. I'm sorry.
Okay.
Are we doing 15 now? Right?
Yeah.
Yeah, we can go to 15. All right. So.
Say one more thing.
Yeah.
She has a really good picture in the first PowerPoint that we're like just finished last class on a semi-permeable membrane where like it's just a really good picture. You should look at that if you're still confused.
Was that the animation thing that she was showing us in class?
No, it's literally just a picture of like kind of like this. If you can see that.
Yeah, I see that. I see that.
Membrane. Yeah, that was helpful for me because I didn't really understand at first. So.
Okay, I'll look it up. Thanks.
Okay, so for number 15, all of the following all the following statements about membrane structure and function are true, except. So the first one is diffusion and osmosis do not require energy input from the cell, which is true. So that's how you decipher. So it's kind of a tricky question because it says all are true except. So that one is true because they do not require energy to push those kind of small cells or water across the membrane. It doesn't require energy.
I don't see the questions. I'm sorry.
It's number 15. It's on the second page, I believe.
What?
In the middle.
It's false. The reason it's false is because Uniport doesn't co-transport.
It's multiple choice question, right?
Yes.
I don't even really understand why C is the answer, if I'm being honest.
Yeah, so I'm going to...
They're saying all these are true except, so we're looking for which one is false. And the whole thing about Uniport is that it can only transport one solute or molecule at a time. So co-transport implies that there's two molecules being transported. Okay. But Uniport can only transport one.
Yeah. So the second one, so yes, C is correct, just like she said. So then I was just going down to just basically go through how I thought about it, how I deciphered what was the correct answer, because when I went through this originally, I did not know particularly. I was confused because we hadn't gone over uniform proteins yet. So the next one that's on the list is B. Voltage across membrane depends on unequal distribution of ions across the plasma membrane. So that's basically talking about membrane potential and later on but it is true. The ions basically determine the voltage of the potential membrane and all that stuff. Anyways, that's the middle one, and now I understand that one, but I didn't before. So I accidentally chose that first because I'm like, I don't even know what that means. So C is correct. Unipotent proteins can co-transport two solutes by coupling diffusion with active transport in different directions. So just like she said, I said membrane transport protein that transports a single species of substrate across the cell membrane using facilitated diffusion along with diffusion. So like she said, uniport, when you think of una means one. So it cannot basically transport two, which means co. So two solids can't diffuse that one. Anyways, that's how I got to it, because of the words. Anyways, so does anyone have any questions about that?
If you need to cover that one more, that's part of secondary active transport. It'll be that part of which we're probably still going to go over that PowerPoint, right? We haven't gone over that. So.
Does anyone have any questions about that? I hear someone.
No, I don't.
Okay.
What did you guys get
move on?
16.
16?
It's A, right?
No, so it's E.
E?
Yeah.
Oh, okay. Got it.
Integral protein.
Yeah, do you understand why?
Yeah, because I have, I don't know, I'm just kind of slow. I have the notes for active transport, and I remember it saying that.
I just have the explanation if you wanted to know. That's why I asked.
Can you tell me?
You can tell the explanation.
All right. So integral proteins are transmembrane proteins that are fully embedded in the cell membrane. Integral proteins are channels that are used for active transport, as it is against the grain going from low to high. So how I deciphered it was I went down the different answers, and I was like, phospholipids, no, that's a part of the cell membrane. Yes, it does let other things in, like diffusion, but it doesn't mean it works in active transport. And then carbohydrates, not really, and cholesterol, not really. So the best answer would be integral proteins. Anything with proteins usually moves some type of solute into the cell or out of the cell. So that's how I kind of remembered it, is proteins. And it's a safe bet. If you have no idea what the answer is and it says, active transport, just remember proteins, integral proteins. Just try to keep that in the back of your head. It's just like a thing.
You said channels used in active transport and what else?
So proteins can also be function in facilitated diffusion. So it doesn't use energy, but they still use proteins.
Protein carrier.
Yes, protein carrier.
I remember that. Hopefully she don't ask a question like the next one, because I remember she said we don't have to calculate anything. Where she said she removed it from her PowerPoint for some reason, she was still there. It was still there, the 5% question. I don't think,
we can go over that now, because
but that one is less about the 5%. It's more about that one is sucrose and the other is no. It's about saying how it's moving. So it's not an actual calculation. You just need to understand that one is swelling and then it stops, and then one actually bursts. So you just need to know that concept. We're not actually doing a calculation.
Yeah, so
thank you.
Yes, exactly what she said. So in number 17, because we're going to go over that too. Does anyone have any questions about number 16? No? Okay. So number 17 is two similar size cells from different organisms are placed in a 0.5% sucrose solution. Cell A enlarges in a size for a while, then stops. Cell B continues to enlarge and finally ruptures. Which of the following was true at the beginning of the experiment? So I chose, or the answer on the what she said was D, I'm pretty sure.
Yeah.
So how it's, the first time we went over this was pretty complicated. I didn't particularly understand it. But so B, okay, just think about B has more of a solute in it or more of a solution where the water wants to come to it more. So you don't know exactly what is in it or how many millimeters or what kind of anything it is, but because the water keeps coming into it until it finally ruptures, means that it was hypersomatic to cell A, which did not burst.
Which is that this is when it shrink.
No, it's when it gets bigger. So hyper means
he's right. Hyper means it shrinks, and hypo is burst.
It's swell, right?
I have no idea.
Well, it's okay. No. The reason it's confusing is because if you're thinking of something in a hypertonic solution, then the cell will shrink.
Yes.
But since it's hyperosmotic, it's something complete. It's something different.
Yeah.
Exactly.
That's what I was thinking.
You're really
That's what I was thinking. Maybe that's why.
No, because I was like, Catherine. No, wait, your name's Olivia, right?
My name's Olivia. Yeah. So
okay.
my legal name is Catherine. That's why it says Catherine.
So Olivia, that's when you were reading it. I was like, yeah, what you were saying makes sense, and then I was like, because I'm like, if I read this by myself, I would probably on the test I would get this wrong.
Yeah, me too.
But
me too.
Hyperosmotic is different from hypertonic.
Hypertonic. Okay.
So hyperosmotic means that it swells because more water goes in, and then hypoosmotic means that it shrinks because more water goes out.
Water go out.
Okay.
That's what it is? I don't know. I'm just repeat after you.
No, I don't know either.
I don't know if you was.
No, because you were saying it, so I thought I was right. I don't know.
No, exactly.
Yeah. So I love how she explained it. So hypertonic and hypotonic is something completely different than this question. So this question is basically measuring the osmotic pressure, or osmolarity. So when you're talking about osmolarity, usually they go over blood, so plasma. So like blood, it has a 300 thereabouts osmolarity. So anything above that 300 mark is considered hypoosmotic. So anything above that is hypoosmotic, which means that it has, oh my gosh, it's complicated. It means that water is going to try to basically dilute it. It's going to go towards it. Now, anything below 300 is going to be considered hypoosmotic. Okay? So in this question, how it's worded, how the answers are worded is very complicated.
Yes.
That's why I did not understand it at all. So at first, I did not understand it. But so basically, it's comparing two solutions, which would mean that we're basically osmolarity. That's what we're discussing. So it's comparing cell B's to cell A. So half the questions are A to B, which most of them are actually. So basically, it's saying that cell B is hyperosmotic to cell A, which means that it has a higher osmotic pressure, which means that there's going to be more solution that wants to go towards it because it's more. Yeah, so it's basically more concentrated than cell A, because cell B continues to fill with water until it
will stop. Oh, okay. So basically, the reason is hyperosmotic because cell B is continual.
Yeah.
And then cell A will stop, right?
So like, remember, it's Jack saying, right?
Yes.
So like, if you remember how we were saying that like, the water wants to go towards it because it has a higher number. So like if you're reading this question, like you can kind of think about it like that. Just imagine that cell B has a higher number, so the water is going inside. And cell A has a smaller number, so the water is leaving.
Okay. I got it. Thank you.
Yeah, so this is very complicated. Now, going through the answers, I was very confused. All of them say A to B. Most of them do. They go A to B or A and B. And then this one says B and A. So I was like, what in the world? Why does it switch now? So maybe that's like an indication that it might be the correct answer. I don't know. Probably not. But she might do things like that to kind of tip you off. Also, it would also be correct to say that, wouldn't it be correct to say that cell A was hyposomatic to cell B because it's less than? So she might kind of trip you up on that. But just know that
no, because it's saying cell A is hypoosmotic to the solution, but if it's cell to solution, we're talking about tonicity, so it's improper to say osmotic.
Yes. So in this question, you're correct. Sometimes I said solution, which was wrong, but it's solution to solution or cell to cell. So that's what we're comparing. We're trying. So in this
no, but that's why A would be wrong, because she put cell to solution, but then she used osmotic.
So I just want to make sure I have this right. So cell to cell is tonicity. Solution to solution.
Cell to cell is osmolarity.
Okay.
Cell to solution is tonicity.
Okay.
Yes. And in tonicity, it would be isotonic would be the solution to the cell. It would be like solution. The solution would be isotonic, or the solution would be hypertonic, or the solution would be hypotonic. So that's the solution would be described as that. And then the cell would be described as something else. What was the cell described as? It was something different. Oh, it would be lysis or
carnation.
It would be one of those two. Or what would be the one where it's just even or like equal to? I can't remember. Just stable. I don't know. I hope she doesn't put that on there because I don't know what that is.
And then osmotic is solution to solution or cell to cell?
Yes.
Both.
Yes. Both.
Yeah.
Okay.
So that's brilliant, guys. I didn't even correlate that. So it's kind of great that I like that we have the study group because I had no idea. So I would have gone.
So cell A itself with the solution is isotonic, right? Because it swells and then it stops.
But then isn't it if it swells when it's
then it's hypertonic.
Yeah.
I mean hypo.
Wait.
If it swells.
Yes.
So it would be hypotonic.
Yes, both of them.
It will be hypo.
Both of them. Yeah, both of them are hypotonic to the solution that in which they're put in.
Okay.
But the question is kind of asking.
I'm just wondering why it stops. Because hypotonic implies it will lyse, right? But then
no,
it's
not always.
Okay.
So she said that it doesn't always mean that it's going to explode.
Okay.
Or implode or enlarge to the point where it ruptures.
Okay.
Yeah. So. Yeah.
You see, like this is a question that I'm like, okay, I get why people are saying to be careful with her questions.
Yeah.
Those questions, come on.
So I just want to make sure I have this right because I'm still like a little confused. So the cell B like bursts and ruptures and it's hyperosmotic because it would be like more than like the 300 like mark that she was using. Yes. Is that right? Okay.
So it's more than 300, but it's comparing the two cells. So it's more than 300, which it means that it could be it could be 400, 500, whatever, but cell A is lower than that. So they could be
because it can continue.
Yeah, so like cell A is like more concentrated and cell B is, I got that wrong. Cell B is more concentrated. That's why it basically enlarges to the point it ruptures, and cell A is below that. So it enlarges for a while and then it stops. So it's less concentrated than cell B. So it's comparing the two cells.
Like I was telling to Jack, saying just think of it that it, like one of them has a higher number than the other.
Mm-hmm.
But I also get you that you have to know what hyperosmotic means in order to compare them. Like.
And I'm still kind of confused with that. So hyper means more, but osmotic is the like which way the water's going to.
Yeah, so it'll be more osmotic pressure.
Higher osmotic pressure. That's what I write.
Yeah, like the water's going inside the cell.
Okay.
And that's why it bursts.
Thank you.
All right. Do we have any other questions?
Did you guys do 18 and 19 last time?
Yeah, we did all of them.
I have a question a little bit.
Yeah.
You said hyperosmotic is when the water has more concentration than the cell?
No, so we're not comparing a solute, which it would be cell, to a solution. We're comparing a cell to another cell. So basically cell B has more concentration of this solute than cell A. So the water is going to want to go to cell B because it wants to dilute that concentration more. So we're comparing basically the solute to one other solute.
Okay.
Yeah, we're comparing the osmotic pressure.
Yes. Okay. So the osmotic pressure would be higher in something that's more concentrated.
Yeah.
Because the water will want to go to that solute more. Okay. Does that help you?
Yeah, that helps a little bit.
So the question will either give you the concentration or it'll tell you how the cell reacts, and like based on that you have to know how to answer it. Because it might be more simple and then say like this is the concentration of this one and the concentration of this one. That one it's easier to understand. So you just have to know what it means if it ruptures or if it. So if oh, never mind.
So have you guys done everything else?
Yeah.
The next one.
Everything on this.
Well, I guess I'll have to go over the Zoom because I wasn't there last time. I was just there for a few minutes and then that's it. So what next? We're gonna move to the integumentary system.
PowerPoint. The PowerPoint for membrane potential.
Resting potential membrane. That's what you mean.
Well, we're behind. Is that where we're gonna start? That's where we ended last class.
Well, we can start earlier. We can go over secondary active transport and carrier active transport.
Yeah, I think because we're at carrier mediated transport is where
we can go over that.
Can someone share their screen like with the PowerPoint?
Yes, I can give over. Yes. How do I like share my?
It should just be at the bottom. Like it should be like a little green box, and it just says share screen.
Yes, someone. I'm on phone, so I can't.
Oh, okay. I can try and pull it up. Give me a second. Which PowerPoint is it?
It would be the membrane transport.
First one.
Yeah, like the very first one.
The very first one.
So I don't get it. Are we just gonna make it through the whole semester just not learning everything?
I'm guessing.
That's like what it kind of seems like.
I said in class that like since last semester, like in the beginning when COVID happened, they had to condense everything a lot. So I guess they kind of have to be consistent with that. So unfortunately on our end, we're kind of getting like the short end of the stick.
Yeah.
But I'm just hoping that what we don't learn now won't like,
affect us in the future
later in the program. Because like our classes now are kind of like the basis for like the program, I guess. So I don't know.
Especially because after Morgan, you said the rate my professor thing, I like logged on to see, and it was like, oh yeah, she's nice, but her tests are hard, whatever, and it's to prepare you for the classes to come. And I'm like, wait, this is what's supposed to prepare us for the classes to come? Like,
Olivia, can you give me like access to tools so I can share my screen?
I heard they kind of set up the questions similar to NCLEX questions to prepare us for the NCLEX, so we're already used to the types of questions.
Like, I don't think we're gonna need to know about cells. Are we really gonna need to know about cells? Like,
I mean, well, for example, when she gave us the example about mannitol and like injecting mannitol, which is a hypertonic solution. So like you do need to know about that, like what could happen to the cell once you inject that to a person. So you kind of need to know about like cells are like the basic, thing.
Do it. I think I did it.
Yeah, it says that Jonelle is the host now.
Okay, let me see. It will let me do it now. Because it's not showing.
Yeah, we see it.
Okay.
Yeah. Just zoom a little bit. I don't know if you can do that. I don't know for everybody, but
right now we're on carrier mediated transport.
Yes, much better. Yeah. Technology people. I don't know if that's gonna be enough, but to be honest, that's the only source that I study on the PowerPoint. And didn't know that I took in class. That's it.
This one, right? Or another slide?
Yeah, this one.
Here, let me just use the background. Oh my God, I can hear me.
Okay, so this I actually understood pretty
decently.
Thoroughly. So I don't know if whoever needs to go over it, or if we should just.
You can elaborate a little bit if you don't mind.
Okay, so for this one, I think that the most important thing is it breaking up. I think it is. Is it?
We can hear you.
Okay, so for this one, I think the most important thing to know is carrier mediated transport is basically facilitated diffusion. It's basically taking something that's too big and using a protein to carry it along the membrane. Okay. I think it's too large to just be naturally diffused. So the most important thing about this is that for glucose or for any type of thing that needs to be used for this, when you're taking it across the membrane, it has specific carriers for that, I don't know how to call it, like for that specific substance. So like for glucose.
Something that looks like it.
Exactly. So for glucose, it's GLUT7 or GLUT4 or whatever. So this specific protein carries it across the membrane. And when it carries it, okay, it can only carry it, or there's only so many carriers for a specific substance. So for glucose, there's only a set amount. So as you can see by the diagram, for simple diffusion, the more that want to go across the membrane, it can keep going, no matter how many. It just keeps going through. Now, for the red line, the one below it, which says facilitated diffusion, for that one, basically only a set number of carriers can go across the membrane.
Across the membrane, okay.
The way that I read like this example that was like, imagine you need to take a bus somewhere, and it's like, you know, the bus can only it only has so many seats. So even if there's more people lining up, more and more people lining up to take the bus, it can only carry so many people, and then you get like that, you know? So the rate of diffusion kind of just like,
tops
off. It can only go so fast.
Like in the
You're muted. You're muted.
Oh, Janelle, you're muted.
Sorry. So in the book, for like the specificity saturation competition, like that's when it's talking about the bus example, and like
that's saturation.
Yeah, like that saturation and specificity is like only specific carriers take specific molecules.
Yes.
And then competition is that like if two of the same molecules are trying to be carried, like they'll fight like to get.
Yeah, so if two are very similar that can be carried, then if you go like somewhere else in the PowerPoint, they show another graph that's like X versus X plus Y, but I don't know which slide it is in the PowerPoint, but like later we'll see. I think
it's 2 slides like down. Yeah.
There. So
no, it
was the one you were just on. Yeah. So it's like X, like one molecule by itself, you know, versus competition, which is the dotted line or whatever, that it's like it'll be much slower if it's two different types because they're competing so it takes longer for them to I don't know, diffuse or whatever.
I wrote that competition and specificity kind of go like hand in hand. Is that true? Because like competition, it's when a molecule looks similar. I don't know. I kind of got lost.
No, so competition is when there's multiple, basically things that look alike. Let's just say two molecules look similar, so they can both fit in the little hole that the protein creates for them to go in and then get carried across. Now, so if there's like I said, there's more than one molecule that looks like it, then there will be basically, they'll both try to fight for it. And basically whoever has more molecules of the same thing, they will get across more faster.
So specificity is only one for that particular carrier?
Yes, except that sometimes there is some that look similar, like some molecules that look similar.
And that would be competition?
Yes. So when that happens, when there's more than one for one protein, then they get basically, there's a competition for it. It's like if you and I like the same person, we would try to compete to get that person or whatnot. But then one's only right or whatever. But that wouldn't really count there.
Wait.
So
in competition, does one of them like beat the other one off the carrier, or do they both?
No, it just slows both of them down.
Okay.
If you go to actually the previous slide, I think it'll show it. So look, let's say there's two that look like crosses, but they're different types. Since they can both go in, it's kind of like, I would think of it like a merging lane. So it's like, you know, instead of them each having their own, they have a merging one. So it's like only one person can go at a time from each side.
I thought she said, from what I understood, was that the one with a higher concentration or higher solute would be transported more than the other one.
Yeah, so yes, exactly. So it's the one that's basically, I don't think it's being pulled more, but it's, if there's more molecules of the same kind there, like if there's, I can't give a good example, but let's just say there's sodium or, I don't know, there's potassium and glucose, or they're probably nothing the same anyways, and one's, but I'm just trying to give an example. So if they're both trying to compete, if there's more potassium ions, there's going to be more, basically more going to get across.
Oh,
right.
Yeah, I'm not giving a good example. Basically, that's not clinically correct. But I'm just saying if there's two molecules that look the same, whoever has more of that molecule, like if there's more sodium or whatever trying to get across at that time that fits in that place, then more of them will get across. If there's more of them.
Okay, let me make sure I have this right. If there's more, like, so I don't know, I'm not going to use names. So if there's more than the other molecule out of two, the one that has the more is going to get across faster.
Yes.
Okay.
Also, keep in mind that they're going to be like really similar too, in order for them to really compete for that one carrier protein.
Okay. I think I got it. Do you want me to go to the next slide?
Yeah, we can. Does anybody have any more questions? No? Okay, you can go.
This one?
All right. Yeah, we can do this one. Does anybody have any questions about this one?
I didn't really write notes for this one because she kind of like skimmed over it.
Yes, she kind of didn't want to give any specific examples of facilitated diffusion, probably because we didn't have enough time to go over it.
But she did mention about, like, I don't know if the exercise and insulin part is kind of important, because she did talk on that, explaining how exercise and insulin.
Know it, but she used it as an example. Right?
Yeah, so honestly, this could be clinically useful. So when you're in, let's just say you have someone who has diabetes or insulin resistance or anything like that, you can basically, it's just saying that when you exercise, it stimulates the cell's ability to transport glucose across the membrane. So it will help them stabilize their own blood glucose levels. Now, I wonder if we have any, I don't know anybody in our program that has diabetes. My childhood best friend had diabetes type 1 growing up. So it's really interesting to, obviously grow up with that kind of metabolic problem. It's very interesting if somebody in our cohort had basically type 1 or type 2 diabetes. It'd be really interesting to see if they could, when we get to that part, they could talk about it a little bit, because obviously knowing we're near the patient on that kind of stuff. So when you're explaining to a patient like they just got diagnosed or their child has or anything like that, it would be really helpful to see if they like wanted to share some of the things that they wish that they were told when they got diagnosed or were found out. I mean, I don't know if anybody in our cohort does have diabetes or anything, or if they want to share anything, but if they did, then it would be really interesting to see if we could like learn what they would like to know when they got diagnosed or when they found out. Anyways, it's just my talk of the day. Yeah.
Do you guys want to go over this?
Does anybody have any questions about active transport?
No, not for me, no.
I'm confused about like the primary active and then the secondary active. Like, I don't really like, because I know like secondary active is mentioned like throughout the PowerPoints, and I think it was like in one of the questions, but I don't really know like.
Yeah, so primary active transport is basically the using ATP to pump a substrate from a low concentration to high concentration. So it helps with the maintenance of certain ions, such as the sodium and potassium pump. That is one that basically co-transports multiple molecules across the membrane. The one that he gives right here is calcium. I'm pretty sure it's calcium. Is that calcium? Does anyone know?
Yeah, calcium.
Yeah.
I don't know. Okay.
So that's another one that I don't know much about that. The book talked on it a little bit more, but the best thing to know is that so in secondary active transport, it's directly basically talking about the sodium and potassium pump. So the first basically primary active transport of the sodium potassium pump is when ATP is used and broken down into ADP. And when it's broken down to ATP, it uses that to catalyze the energy to pump two potassium inside the cell and 3 sodium outside of the cell. So it's basically just trying to pump both of them in either direction. It's using the gradient from low to high. So that's how you think about it. Now, for secondary active transport, it's basically talking about using that basically the constant. So they using the sodiums. So sodium by having the sodium potassium pump, the sodium has such a high osmotic pressure from I don't know that it wants to go into the cell so badly that it will use the same pump, one sodium ion and one other ion like glucose, and it will pump back into the cell. So but it just uses, it's hard to explain, but it doesn't use any energy, but it's
I have it written down. Yeah, it indirectly uses ATP.
Yeah.
But it's still energetically favorable.
Yes, because of the fact that the concentration gradient of Na outside of the cell and Na or sodium inside the cell is so I don't know, like high, or it's so high outside and so low inside that basically it's energetically favorable, so much so that it will literally carry another cell with it to get back into the cell. Because
I have something here that she wrote, it's like, I guess, verbatim, that the most important thing to know about secondary active transport is that it's a secondary active transport process, something that uses favorable energy associated with moving one thing down its concentration gradient to move another thing against its concentration gradient.
Yeah, the glucose would be going against its concentration gradient because the sodium is being pumped back into the cell.
Exactly.
And it's going from high. The sodium concentration outside of the cell is high and inside of the cell it's low. So when it's being pumped from the outside back into the cell, it's favorable because it's going from high to low. But the non-direct energy for the, let's say glucose is being pumped back in with the sodium, it's using the broken down ATP, which is technically ADP, to be able to do that. So it's called secondary because it's not directly fueled by ATP, if that makes sense. And I
remember earlier she said something about it being like a waterfall, or I guess like a dam, moving a turbine. Something like that. So that like it'll move, but it's not doing it with its own energy. It's because the water is coming and moving it. If that example makes sense to you. It makes sense to me.
I'm just gonna watch a video on it.
No, the videos are really confusing though.
Because I'm so confused with the
I can explain it to you if everyone wants to move on. I can explain it to you, like, because I feel like I have a good way to explain it that it's not confusing. But if everyone wants to move on, we could just.
No, you can explain it now because, like, I feel like I kind of understand it, but I'm, like, not quite there yet. So if you have a better way to explain, then
sure,
go right ahead.
Okay, let me just pull it up. Okay, so primary transport is, I'm going to use the example of the sodium potassium pump because that's the only one I know. So let me just, okay, so it is using, okay, so it's taking three sodium ions out of the cell and 2 potassium ions go into the cell. To be able to make that happen, you need 1 molecule of ATP to do that original movement of like them switching places. So that would be considered your primary active transport. Both of them are going from low to high. So that's why the ATP is needed. That would also be considered, I think that one is the antiport. Correct me if I'm wrong, but I think it's using the antiport antiport protein because you're bringing more than one in opposite directions. Let me just, and then it's also considered like electrogenic because it's making the inside of the cell more negative than the other side. And then secondary, wait, does that make sense or did I just confuse you guys?
So you said that because it's taking 3 sodium out and putting 2 potassium in, it needs ATP because it's going from low to high, right?
Yeah. Mm-hmm.
And then it's also a part of the antiport protein.
Yeah.
And then it's electrogenic, right?
Yep.
Because the cell is becoming more negative.
Yeah, because you're taking 3 positive ions out and you're putting 2 positive in, but it's like making it more negative because you're losing 1 positive ion.
Okay.
So the definition
That's also the premise for resting membrane potential.
Wait, sorry, could you say that again?
That's also the premise for resting membrane potential.
Mm-hmm. Mm-hmm.
So like antiport is 2 particles and 2 different directions. So that would be the sodium and potassium, but one's going from outside to inside and one's going from inside to outside the cell.
Mm-hmm. Okay. Does everyone get that? Can I move on to secondary active? Okay.
Yes.
Okay. So secondary active is, so the sodium was taken out of the cell and the potassium was put in the cell. So the sodium is currently on the outside of the cell. And if you know, the sodium has a higher concentration outside of the cell than being inside of the cell. So for secondary active transport, a substance, I'm going to use glucose as an example, is pumped from an area to low to high concentration. So both of them are being pumped from the outside of the cell and going into the inside of the cell. So the glucose going from low to high would need energy, but it's considered secondary active transport because it's not directly getting an ATP molecule. It's using the broken down ATP molecule, which is ADP. It's using that energy to be able to bring the glucose from low to high. There was another way that
So ATP, so glucose is using ATP indirectly from the primary active transport of when it was broken down, right?
Yeah.
Okay.
I had something to say about that. I forget. Okay. It'll come back to me, sorry. Okay, so okay, I remember. So in the primary active transport, the ATP is used to make a sodium gradients. So it's using that ATP to be able to bring the sodium from low to high. So it's using energy from the sodium gradients, how that was made. So like going from, okay, sorry, don't want to confuse anyone. Okay, so then the energies, so they're using, it's not direct energy, and both of them are being transported into the cell. So that would be symport, because I think it's two going in the same direction. I think, right?
I'm pretty sure. I think we're going to get into that in the next slide, or the next couple slides. I think it goes over that a little bit more. So I just re-jog our memories. I know I probably wrote it down. Molecules in symport move in the same direction. Antiport molecules move in different directions. So you're right.
Yes, it's simple.
Yeah, totally.
And does anyone have any other questions? Like, did that make sense?
So, for secondary active transport, you're using glucose as an example, right?
Mm-hmm.
Yes.
So, like, it indirectly uses ATP because it uses the broken down version ADP.
Mm-hmm.
And it's going from low to high concentration.
Yes. Oh, and another thing,
it's not from high to low, because the active transport, you said it's going from low to high. The primary is low to high, the secondary is the same thing.
The molecule would be going from low to high. That's why the indirect
glucose molecule.
Yeah, the sodium wouldn't need any energy to get back into the cell because it would be going from high to low concentration. So you don't need energy for that.
Okay.
But whenever she was saying it, like the definition, the point is that it's using the energy of one thing going down its gradient to move another thing against its gradient.
Yeah. So the sodium would be going down, the glucose would be going against. Is everyone good with that? I hope I didn't confuse anyone.
No, it made sense, but I'm still gonna watch a video. But like what you said, it made sense.
I would, what really helped me, because I looked at videos too, I would just listen to how she explains it in the lecture, like recording, because that made more sense than any videos that I watch. But that was me personally, so do whatever you want.
Okay, you guys want me to go to the next slide?
Yeah.
We all good on this? Do you want to go over this?
So we can go over the co-transport and the so basically what it means, like she explained it perfectly. So in symport or co-transport, so just do symport because it's a little bit more differential. So symport, molecules are moving in the same direction. So it gives an example, sodium / glucose in the kidney tubules. So they're both going in the same direction. Like if they're both in the cell, they're going out of the cell. If they're both out of the cell, they're coming into the cell. Now for antiport, they're moving in opposite directions. So just like what she said with primary active transport, they're both going in opposite directions. So the an example, Na is coming into the cell, and potassium's coming into the cell, and sodium's coming out of the cell. So they're going in opposite directions. So that's just, I hope I didn't confuse anyone more, but does anybody have any questions about that?
I feel like if you look at the next slide, it's easier to explain because you can like see a visual of that if anyone's confused.
Someone just said in the group chat that the exam date was changed for AMP.
Yeah, but I got a notification from Canvas that said exam date changed, but when I clicked it, it was just a Zoom. I mean, it just said event date changed.
Yeah, I didn't see, yeah.
It wasn't.
I don't know how to get the link back, but I got it and I just lost it.
But I think it was just a Zoom link for tomorrow.
But it said 11 a.m. to 3.
That's weird.
Wait, are you talking about this?
So basically, what the person said is the exam date is not changed, right?
I don't, because like Canvas said exam date changed, but when I pressed on the notification, it just took me to a Zoom link, and the Zoom link, I'm pretty sure it said 11 a.m. to 3, but now I can't find the notification.
But that's the thing, mine said, it said event date change, and
Yeah,
it said
mine said
September
event
4th,
date.
which is tomorrow. So I'm thinking that that's just the Zoom link.
But I literally cannot find where it went.
Got excited.
Because like when I go to the Zoom like section on Canvas, it still says tomorrow at 1.
Yeah, I don't know. I saw
Yeah,
it too.
earlier it was saying tomorrow at 2.
Yeah, it just says 1-5.
Can someone? I literally don't know what to do. Oh, here it is. Yeah, it says.
Where'd you find it?
Okay, so I went to the calendar on Canvas, like on the app, and it says tomorrow. It says the class is September 4, 2020, 11 a.m. to 3, and it's like the Zoom link for tomorrow.
Yeah.
Okay, perfect. Yep, see it.
But that doesn't make sense because we most definitely have the other class until 12.
What? Wait, I'm so confused as what
Wait,
is
what?
happening right now.
No, it's at 1. It's not at 11.
Maybe it's not for us. I don't think so.
Yeah, I'm not blind. This is 11 a.m. to 3, right?
No, I don't say you lying, but why would they make a mistake? Because the other class in at 12. How are we going to make it?
I don't know.
Yo, we'd be on 2 Zoom
September
classes like at one time.
September 4th at 1 p.m.
That's weird because mine says 11 a.m. to 3.
Didn't you say you're not in Florida?
You're in a different. I'm dead.
Sorry, guys. Sorry.
Damn date change. What? I'm so confused.
Yeah, it like automatically changed the time on my phone. I was so sorry.
Oh, I didn't even realize that. I was like, shit.
Sorry. Okay, ignore me. Back to learning.
It's okay. You living your best life. That's all right.
Oh, yeah, so you have to make sure that you're up earlier. Whatever.
Yeah, like
you have to like 6.
Yeah, I'm a peer leader, and we have class at 8 a.m., so I had to get up at 5:30 because class was at 6 this time. Yeah.
Oh. No. Good.
That's
all right.
I'm muting myself.
I will, Jasmine. As soon as it sends it to me, I'll send the recording in the link or in the chat or the the group.
All right. Bye, everyone.
Bye. Oh, goodness. Bye.
Wait, I'm still really confused. Why did someone say that the test changed?
Because I think they thought it said exam date change, but it just said event date change.
Yeah, because I was like, what? Okay, sorry. You can continue wherever we were.
Wait, where did you find the link for class tomorrow for anatomy? Because everyone's saying that she sent out a link, but I didn't see it.
I went to the calendar on the app, and I just went to the Friday, and it was there. And you press the actual event, and then the link was there.
Did you find it? It's zoomed in a lot. Maybe it's just me.
Yeah.
It's probably just me. Okay.
Did you guys want to go over this?
This one was easy, right?
Yeah.
I think we just need to know the definition for that. She didn't really go into.
Yeah, it's just bigger than facilitated, or.
It's basically transported. Sorry, you can go.
Sorry, it's too big for too large for a protein carrier.
Yeah.
That's what I have.
Yeah, so, and the endocytosis and the exocytosis basically means it's transporting molecules through vesicles. So either sending them out of the cell or into the cell. So endocytosis, I believe, is into the cell, and exocytosis
is like exit.
Yes. Someone said something in the chat. I don't know. Do we have to know the atypical regions in basal? I don't believe so.
Yeah, she didn't even mention that really.
Yeah, she didn't go into that at all.
I just have a question. So Are we finishing this PowerPoint? Because there's still a few slides. Like, does anyone know what we're going over tomorrow?
She said she's going over resting membrane potential again. And then I assume she would just try to start the neuro stuff.
Okay.
So
and then
finishing out like this PowerPoint, or we're just stopping after resting?
Well, I think like the rest of the slides all apply to the resting membrane potential, if I like remember.
So I went over the rest of the slides on my own and they all made sense to me. So I mean, I know that Emily, that's your name, right?
Yeah.
It is. Yeah, so Emily, we talked about in the beginning, and we're kind of confident on that part of the slides, and they kind of just went off of what she said. It's basically just a continuation of what she said, so it just further going into like the specifics. So we can go over that tonight. If we're confusing everyone, then we'll just wait until after she explains it, and we'll go over it in next week again, probably too.
Yeah, that's fine. I just like don't know what to download for tomorrow. Like, I'm assuming for anatomy we're doing the nervous system, but I don't know which we'll be doing in physiology, I guess is what I was asking.
Yeah, so we're doing, yeah.
Did we finish? We finished this PowerPoint last week, right?
No.
No.
She just started it, like started the resting membrane potential.
Wait, so which PowerPoint did we do last week?
The same one.
The same one from week 1.
Oh, I thought we finished this slide last week.
No, we're so behind.
So she
that we're on the first PowerPoint.
So she only stopped at this slide last week, right?
Yeah, and she explained it like extremely briefly, and then was just like, we'll go over it again next week.
Oh, so I've been stressing myself out about getting caught up on these notes, and we're not even like doing anything. No. I've been like literally like every night. I've been like you guys know that like sound. It's like like I've been literally doing that every night because I thought I was so behind in everything. But
I literally love that video. Like any meme that's made with that video, like I make that noise. I don't know how many times a day. I'm really happy.
So like I'm so far ahead. I'm chilling. I'm done.
Actually, I don't know if you're chilling because we still have to do all the thin notes, and I don't know how much of the nervous notes we have to do.
No, because I already did. Like I read chapters 3, 6, 7, 9. Because like 7 and 9. Well, 9 is like nervous system. So I did that, and I did the autonomic nervous system PowerPoint last week. So then I was like, dang. I was like, I have to do chapter 18 too. Because I thought we finished this PowerPoint last week.
Nah, you're chilling. What you just told us, you're good. You read the nervous chapter?
Wait,
Are you kidding me? I looked at that and I was like,
yeah, so I know literally I finished, like I didn't do it like in depth, but I went over chapter 9 because I thought that's what we were starting tomorrow. And like I just took like the book notes, like you know how it gives you the summary of stuff? I just like went over that for a class because I thought like we were doing that, but.
Wait, so you guys think it'll be on integumentary system, this cell stuff, and then like she's not going to be able to get through like a whole other PowerPoint tomorrow. Like it literally takes her 3 hours to read like 20 slides. So I'm like confused what is your test really going to be on?
So I'm pretty sure it's going to be on this and then nervous.
She might just have to skip around with the nervous system, like pick and choose what she wants. But aren't the tests, like, does she make the tests or are they already like pre-made?
No, she makes them.
She makes them because she said if I have to look at a model to write the question, I won't do it.
Okay. I'm pretty sure, like from what I've heard, is that all 3 campuses take the same exact test, and we all get the same test like written by the main instructor. So I'm assuming that's her because Miami doesn't have an instructor. So yeah.
Yeah, she is like the only anatomy, I think, for like all 3 campuses.
Fort Myers too?
I mean, Fort Myers was in her class the first day.
Oh, I didn't even know that. Okay, I think I'm just behind.
Yeah.
All right, so
when I like first signed up for class, it said Lyons, Fort Myers. But yeah, anyways.
We don't know. So for the resting membrane potential, it's basically the membrane voltage across the membrane. So it's hard to explain, but basically it's the difference in charge across the membrane. Using this slide, basically it's using the or the sodium potassium pump to maintain the gradients. Now, if there was perfect gradients, it says that the voltage would be -90. So that means that if basically it's saying if no sodium was allowed inside the cell and no potassium out, it would be -90. So that would be an equilibrium, which just means that everything would be even. Now, we know that that's not the case because sometimes, like through the secondary active transport, sodium can get back into the cell, which lowers the membrane potential voltage to about -70. So you're going to see that -70 is basically what it is. That's just what it is. I don't know how to explain it.
Okay, so I'm going to try to explain it as simply as I can from what I learned from this YouTube video, which is like from the sodium, sodium potassium pump, since from that, the inside is becoming more negative than the outside, that alone is making the difference -5 millivolts, whatever the thing is called. So it'll be -5, but since there's some channels that leak potassium also, it goes to -70. So the difference from the inside to the outside is -70 as far as the charge.
Yes, exactly. So it says some other factors. Yeah, you go.
So basically the resting membrane potential, like it's supposed to be a difference in voltage.
Yes.
Because like in the book it says maintaining potential difference across the membrane. So like the inside is supposed to be negatively charged compared to the outside.
Yeah, so what like resting membrane potential is like the state it's in for it to be ready so that when it's excited or stimulated, the right things can happen. But like, that's why I'm still confused, and that's why she's gonna go over it again. I don't know what the main thing for us to focus on is, if it's like to focus on -70 or if it's to focus on, I don't know which part of it she wants us to like really pay attention to.
So from my understanding, like -70 is the resting membrane potential.
Yes.
And then when the chemical gradient and the electrical gradient reach an equilibrium, that's going to be the -90.
92.
No, -90. She said -90.
-90?
Yeah.
Okay.
I think we watched the same video because I think he did -90 too.
Yeah, that's probably why.
Yeah.
I watched like 2 different videos. Okay, -90.
And you said when the electrical gradient and the chemical gradient
are at equilibrium, then it would be -90. So that gradient alone is -90 millivolts. But hold on, let me read my notes.
Yeah, so what she's talking about is the electrical and the chemical gradient. So let's just talk about the potassium. So in this, she used a specific example. That's why I'm using it. So for the chemical gradient, it wants potassium out of the cell. Because of the fact that it wants it to go from high, which is inside of the cell, to low, which is outside of the cell. That's what the chemical gradient wants it to do. Now, the electrical gradient, what she's also talking about, is that it wants potassium inside the cell because it wants to be electrically favorable, or basically just it's a whole bunch of things that we're going to get into the muscle. So what she keeps bringing muscles into this, it's because of basically the connection also in neurons and all this stuff. It's the connection to basically send electrical impulses through. That's way too complicated, but that's just basically what it does, and that's why that it wants it to be inside the cell. So I don't know exactly. I know that the electrical gradient wants it to be at -90 millivolts. That's would it be equilibrium inside and outside the cell, I believe. So that'd be equal potassium inside of the cell to equal sodium outside of the cell. And like she said, that usually stable when it's at 70 millivolts, it's 150 millimoles inside the cell of potassium and 5 millimoles outside the cell, which makes it stable for potassium. That's what is right there. Okay, so on this slide, it says fixed ions, which I had no idea what that meant until I read a little bit further. It just means that there is fixed ions inside of the cell, which are potassium. So they're fixed. That means that they stay there and they can't leak out. They just are they're like starfish. They just like stick on the walls. But I don't think she's going to go like specifically like what they are, know exactly, because I'm pretty sure she wants to skim through. Now I could be wrong. She might go like deeper into it and I would not know what I was talking about then. What else? I don't know anything really else from this slide. Does anyone else know it? No one? I'm alone.
I don't know anything, but I'm waiting for her to explain it because I'm a little confused.
What are you confused, like specifically on?
Because I thought resting membrane potential was just like what the membrane was at. Like it was just like its flat state. So I didn't know that like so much went into it.
Yeah, it's pretty complicated, but like a basic definition of it is the difference in charge across a membrane. And what you should really know is that what it is normally is negative 70 millivolts, or is that the example that she provided? That was like what it normally is.
Yeah, like so that the inside of the cell, and that's negative 70. Yeah, like assuming that it's 0. So, but it's just like that the inside of the cell is more negative than the outside. But I believe, aren't they like both positive, technically?
Oh. I think potassium is negative. So every time it leaves the cell, it makes the inside of the cell more negative. That's why it gets pulled back in to fix the charge.
Yeah, you're right. Yeah, so yes, potassium's more negative, and it basically is more inside the cell. Sodium is more positive, right? Pretty
yeah.
Sure. Or that's its voltage. It's more positive. So, like, an example in the PowerPoints we're going to probably keep going, which is if the membrane was only permeable to sodium, which means that sodium was only permeable inside the cell, it would be 66, like plus 66 millivolts, which means it would be positive. Now, because of the fixed ions that I talked about the potassium inside the cell, it's going to automatically be more negative. So I'm pretty sure that I did a lot. So, because vitamin K, oh goodness, not vitamin K, I'm going to start going into vitamins. Potassium is the most permeable ion, which means that it's basically permeates most permeable. That's what the thing says, but it's the most determining factor in membrane potential. So that's like, I think she wants us to focus on potassium especially. That's why she gave the examples of the chemical gradient and the electrical gradient, I'm guessing. So yeah, who knows? This is pretty complicated. I think I'll be able to explain more if we go further in. Does anybody know, like, after fixed ions, like what specifically did that mean?
I literally just stopped at resting membrane potential, so I knew like what the basic like understanding was. I didn't look any further because I'm kind of already like stuck on it. Like I texted her and asked her questions and she explained it to me, but I need to sit there and like reread our text so like I make sure I understand, but I didn't get any further. I didn't even, the only reason I knew about the anions was because of this video I watched, but I didn't know what he was talking about.
I'm scared to see what the next slides look like.
No, so they're not that bad. Just go back to them. I can explain them, but I don't have it right in front of me. Maybe I'll pull it up.
Okay, wait.
It will help me explain.
She might not even like put that on the test if she's rushing. Like she might only want us to know like the simple things, but I guess we'll find out tomorrow.
Yeah, we won't know until tomorrow.
So on the, yes, go back to the slide you're on with the, one more. Okay, so right there it says on the top, vitamin, or I keep saying vitamin. It's like I'm back in nutrition class. Okay, potassium is more permeable than other ions. So that just means that it wants to be in the cell. It's the fixed ions that I'm talking about is the potassium. They're attracted to it. They want to go near it. They want to be next to their friends. But later down the chart, so membrane potential, the literal definition is the charge difference across the membrane. So this potential difference is measured in millivolts. So it says positive outside and negative inside. So just like, oh my gosh, I need to get better at names. I mean, I don't know. What if somebody who was really good explaining the active transport, she also explained the positive inside and positive outside. So the positive outside would be the charge of the sodium. So it wants to be, it is positive. It's your best friend. Sodium's your best friend. Let's just say that. And negative inside is like the negative inside thoughts. You know, you think about, you know, negative stuff. Okay, just think about it like that. So potassium is negative and is shown in negative volts. Okay, potential difference, like I said, is in millivolts. Other ions contribute, but potassium is the most important, just like I said in here. And it relies a lot on the concentration gradient, like how the sodium-potassium pump transports the sodium outside of the cell and potassium inside of the cell. So, and then it says again that potassium is the most permeable, which I'm guessing means that it's easily goes into the cell. Okay, that probably doesn't make any sense to anyone, but I tried. What's the next slide?
Can't breathe without filters.
Okay, so this is what I was trying to...
What I feel like is that, like, I don't know about you guys, but like this, I feel like no matter how much I look at it right now, I'm not
going to
get it right now. So I feel like I'd rather go over this, like maybe like start something else if we're still going to study now, just because we're probably will benefit more from just like waiting for her to explain it tomorrow.
Yeah, probably.
Like this, I can't.
Like my summary. I feel like it's pretty good, and I've worked on it for like the last 3 days. So I can just put it in the chat, and if it makes sense, you can copy and paste it. If not, whatever.
Can you put it in the WhatsApp?
Yeah, sure.
Thank you. Yeah, like I'm not gonna really get this until she says it, because like even reading it and doing the notes myself, I don't really understand it. So I need her to like break it down, then to go back and dissect it even more, because like it's confusing me.
Yeah, I'm still trying to like digest the resting membrane potential and like fully understand it before I go on to something more complicated in the resting membrane potential.
Wait, do you want me to send it in like the what's it called, the Zoom chat, or you want me to send it in the big group chat?
The big
probably
group.
the big group chat.
Yeah.
Well, I hope it's correct. I mean, like basically what I did is what really helped me was drawing the cell and like kind of how she did it in lecture. I don't know, maybe it'll help someone.
I feel like you should put it on that Google Doc that Michaela set up, that she was like,
I can do that too.
What are you sending in the group chat?
Like just that I summarize the resting membrane potential, and it like makes sense to me, so I feel like it would make sense to other people.
Okay.
I don't know if it'll actually help anyone, but it made sense to me.
No, I need to look at pictures sometimes, so yeah, definitely send it.
Okay.
Yeah, and whoever was that, Michaela, that sent those beautifully written notes?
Yeah.
Oh my gosh, bro, her handwriting is goals. Like I just want to like print those, like just to look at them, and like I aspire for my handwriting to look that beautiful. Anyway, so like I don't want to confuse anybody more, and I think we should let her explain it, because she's gonna be, I mean, literally she'll explain it so well, I mean, like she did last time, that she just kind of like, oh, here it is, and this is how I explain it, and she'll tell you what's the most important, like she'll reiterate what she thinks is the most important, what's probably going to be on the test. So we should probably we could move on to the goodness. You know what I'm talking about.
Integumentary system?
Yes. The augmentary system. I got it. The augmentary system. Did I say it right?
Someone in the group chat wrote, huh?
Yeah, I know. I'm like, that's gonna be so confused.
They're like, what the heck, bro?
She's trying to get this bitch out of me.
Well, if you joined our Zoom, you know what the fuck we're talking about.
Sorry.
Yeah, that's true.
I didn't know you were saying.
Oh my god.
Next day, you've been so quiet for like.
No, guess what? I just get out of the shower. I had to. I'm sorry.
What's the point of being here?
But I connect my phone to my speaker while I'm inside the shower, so I can listen to you. I just did not speak. I just get out from the gym. The sweat was too much. I had to take a shower. I'm sorry, y'all.
Dang, you're dedicated.
I'm literally gonna say, "Hey, I'm back, y'all," but you already,
He said, "We don't listen to music in the shower. We listen to lectures. We listen to the Zoom."
So, are you guys gonna cover it? You guys gonna stop there, or are you guys gonna cover the integumentary system too?
So there's I don't know, probably 7 other people. I don't know how many people are in the chat. So, would it be better? I mean, I know some of you are on mute. Would it be better for me to go on, even though I'm not as good as she is, or would you like to stop here and go into the augmentary system? I think we're going to do it either way, so it's up to you guys or everyone.
I would say, in my opinion, the fact that, maybe she's going to tell us which is more useful, I would say wait until she go over this and then move to the integumentary system. I don't know about someone else, but that's what I would do.
She's going to go over this anyways. I feel like we should just move on. Like, if you're willing to, like, still stay on here now. My thing is that I haven't taken all the notes, so I would just be taking, like, I can't contribute that much.
Yeah,
taking notes right now.
It will be confusing for us if we continue.
And if I'm
without
being
her.
honest, when Dr. Berryhill was going over and she was like basically saying that like we didn't really need to know anything difficult, I didn't want to stress myself too much with the integumentary system too. If there's no need to be stressed out.
I thought I don't think funny. She was like, oh, when she was asking about WBC, she's like, yeah, you guys don't know what that stands for. I was like,
white blood cells?
I'm like, what do you mean?
She's like, you guys don't need to know this advanced stuff right now. I'm like, this whole thing is a review.
I know.
That's what I said. I was like, what? Wait,
there's like, you don't need to know
advanced here
of the epidermal layers. I'm like, what? That's literally so important.
I'm like, I had to memorize all that in AMP1. I'm like, now I just have to know like barely like half of them. I'm like, thank you. But
so, and like she, like the most of her lecture was just stressing the different skin colors. So that's why we can go over it, but like how Emily was saying, I don't have much to contribute just because I haven't done the notes yet. And then also like, I'm trying to not stress myself out about that just because she made it so easy.
Yeah, it's pretty straightforward.
So like, if you guys want, we can go over it like next week before the test, maybe
definitely.
Yeah, I don't really have a problem with that anyway.
Yes. Yeah. So
like, I think I got it. Like, cyanosis,
different
blue.
Zoom days instead of just like trying to cover everything in one day.
I feel like next week should be like a big review day. So like maybe like we'll kind of set it up how they do it in class. Maybe like we'll do like a 2-hour or 3-hour Zoom or something. We could do like an hour of anatomy and go over the integumentary system if it takes an hour. And then after we can review everything from physiology starting from the beginning and see if we have any questions. And I'm sure Saturday's like session will help us too. Like asking her questions and everything.
If I'm being honest, after realizing that I'm ahead, I'm chilling. I'm just like gonna calm myself down because I've been so stressed out, like thinking that I was behind this entire time.
No, just breathe.
Nope.
You're okay.
You're not behind, girl.
Like I was like literally on the plane yesterday, like trying to go like through the book on my laptop and stuff like that. So I'm calm now.
But the book might stress you out though, yeah.
Yeah, it does.
The book goes in too much depth, I think. But if you like read what's on the PowerPoint and then look at the book, I think that's helpful for sure.
So that's it for today?
I think so, unless anybody has questions.
So, I mean, does anybody have any questions about the augmentary system or anything like that? Because we probably next week when we go over all the review and all that stuff, it will be a little bit, like we won't be able to like go in depth on any concepts or anything like that. I mean, other than, unless I wasn't present, because I just had to go answer the door. But.
No, good. Well, I just haven't really started it.
Oh, okay.
So that's why I don't have any questions.
Is everyone I understand everything we've gone over in physiology, but like I made I made flashcards of the like anatomy for the integumentary system, and I'm like stressed out because there's so much to memorize, even though there's not that much at the same time. Anyone feel the same?
Physiology stuff, like after reading the book and then the Zoom calls and like writing little notes on the questions, I'm like I'm starting to understand it now. But then with the like integumentary system, even though like it is review, it's still like a lot to cover.
Like there was
because like Dr. Berryhill, I don't think she was like very. I didn't really like
the PowerPoint. I
didn't really like her teaching, but I did like the fact that she like use like clinical applications.
Yeah.
For everything like that really did help, but other than that,
so fast.
And like I have friends that are like in their third semester, and they said that like they don't like her as a professor like at all. That like they basically have to teach themselves. Because like I think my friend like has her for med surg, and she's like that she's basically teaching herself.
Wow. Well, you should ask your friend, is the test gonna be easy too? That's what worries me, to be honest.
But no, like everyone that I've talked to, they said that they love Lyons, that like to just go over her PowerPoint and like the stuff that she says in class, and like you'll be okay.
But like
okay, that sounds good so far.
Like my flashcard, like look how.
Yeah, that's why I'm like stressed the fuck out, because I have like 100 flashcards off of everything she said to study, and all of them have like 14 bullet points. I'm like, how am I supposed to study this?
I know. And the composition of the dermis, like, excuse me.
Yeah, literally.
No, that's too much.
But then it's confusing because she's like, the epidermis, you just need to know that it lies on top of the dermis and it has a rich blood supply. And I'm like, it doesn't sound right that that's the only thing we need to know.
I'm sure it's so funny because like literally every slide she was like she would be like look at it and she'd be like, next slide.
She'd look at Dr. Lyons and she'd be like, they don't need to know this. Like asking her.
Like she would like read one word, she'd be like, dermis? No, next slide. Like, okay.
She'd be like, it's too advanced for you. I was like, what?
And I was like, we literally learned this last semester in like A&P, so is it too complex for us?
I think that a better way she could have explained it would probably been like, oh, well, this is very specific. You should know this clinically or like for later semesters, but it won't be on the test. Or something of the sort. Because I understand like it's only 15 questions of the test, so they can only ask so many questions on each topic, you know?
Yeah, because it's integumentary and it's gonna be nervous, so
yeah.
And no one's gone over the nervous system yet for anatomy at least.
Tomorrow, I think.
So like the PowerPoint where is the paper that I have? So, like, is this for Dr. Chang or is this for Dr. Berryhill? Because, like, this is, like, because, like, this is the PDF that was, like, under the modules or whatever, and, like, I just printed this out straight from Canvas.
Yeah. Did anyone look at that freaking nervous system anatomy? I literally had a heart attack. I was like, I don't remember any of this crap from A&P 1.
I went over it, and it is review, and I like the way that she set it up. Like, she basically has like notes for every page.
Is it the organization of the nervous system? Is that
Is that the same one? Wait, is that the same one?
Yeah, it is.
Yeah.
Okay.
I think that's
what. Where do you guys get this?
If you go on Canvas and look under modules, like I think it's under week 2. It's something like there will be a box that says anatomy, and then under that box it will have like 2 things, and it says nervous system, and it's a PDF, and it's literally just like a big packet going over the nervous system, and then like for every page she has like notes to go along with it.
Okay, got it. I'll do that.
Did anybody do the title page yet or anything for?
No, I haven't even read it for it to be honest.
I don't do anything. I'm just waiting for tomorrow.
Because she loves you.
Yeah.
I mean, not really, but I don't know.
She's always saying your name. She's always like, Jack Saint.
Yeah. I wish she was doing grading me, but she don't. So I'm like, she don't grade my paper though because of my last name. The other one grade my paper.
Oh, Connor.
Yes.
Yeah, but she's your advisor, right?
Yeah, she's my advisor.
Yeah.
Yeah, I have Dr. Lyons as my advisor too, but she didn't say my last name.
I don't know. My advisor's like Donna or something.
I have BB.
And the one time I emailed her, it was like, "Oh, I'm on vacation, so I'll get back to you when I get back."
What the?
Same.
So.
Wait, but is page 2 also like? Is that already getting into the information?
No.
Yeah, that's the introduction, I believe.
But that's not until next week, right?
Yeah, but
it's Monday too.
But I think she said the date's gonna change because Monday is a holiday. I'm not sure.
Oh yeah,
but that's for Monday.
Right. But so the title page is supposed to be due Monday?
No,
supposed to.
The next day.
It would be due Monday, and she'd go over it tomorrow in class. But I think she's gonna change it to Tuesday or Wednesday, the due date, because we have no class Monday.
But they are going over it in class, right?
Tomorrow, yeah.
Okay.
They'll go over exactly how to set it up and everything.
Wait,
but
are
I
we
didn't know
supposed
if
to read before tomorrow?
Yeah, there are readings, but I'm not reading it.
I don't do any reading.
I read it because she called my ass out, and I was like, I literally said, I was like, I'm sorry, like I couldn't hear you. My connection was bad. She's like, well, you need to fix that. And I'm
At least you had an excuse.
No, I didn't. I don't read for that. I haven't read for that class because it's just like basically telling you how to do certain things like grammar, punctuation.
It's so retarded. I read it the first week, and I knew she was going to pull some stuff like that because she was like, you need to read, guys. You need to read. You need to read. I know I call you guys out. So I read the first week, and then I realized that it was all in the freaking beginning of the chapter. So I was like, what is the point? And then I realized that the readings that she gave for last week, a lot of them are the same for this week. So
yeah, so I just make sure to have the book up while like I'm in class.
Yeah, that's exactly what I do. When she say read, I just read from the page. And then I just feel like this class is, I don't know, useless to me because...
Yeah, this is like our unit class.
Are we going to have to write multiple papers in the program? Like in other classes, we are? Okay.
Yeah, you have to write... I could be wrong, but my friend said she had to write a good amount of papers. Like she was just sorry, I thought that was me. Her 6th semester, she was still writing papers, so...
Okay.
Yeah, I think that's the research paper. 6th semester, this is where you had to do research on medical stuff. They mentioned it on there. I don't know, but that's not essay or ATP because I hate writing. I'm not gonna lie to you guys. I'm a terrible writer, but
yeah.
Has anyone had their sources graded?
No.
I didn't even have my in-class activity graded from
they still haven't put their grade.
Anyone has it yet.
Yeah, no one.
I just want to make
sure. I guess they're gonna put them all in total. Mm-hmm.
I don't know.
All I know is I better get points because she said whoever was there was getting points. So
yeah.
Yeah, because I didn't turn that sheet where we went into the breakout.
She just took it. She said she was gonna just look at the attendance.
That's what I thought, but I was like, since maybe it's taking longer, like, was I supposed to submit it?
The girl that like sits in the very first row. I don't know if you know what I'm talking about. She asked. Yeah. Overheard, and she was like, "Yeah, we're gonna grade it. We just haven't had the opportunity to yet." So
okay.
Yeah, this scares me. I've never been graded on a point system before. Well, I have. Okay, I've never been graded on a point system to like this degree where there's like 100 points in the class and like you have to get every single point, and like if you get like 4, like less. What is it? It's a 94 is an A, and then anything below is an A minus. I'm like, oh my gosh.
I've never had like A+, A-. It's always been like just A, B, C.
No, B, C, yeah.
I hate about Nova.
That like messes with your GPA more. Yes. Like when you have plus and minus. I know FAU does that, and I'm like, oh.
Yeah, I learned that freshman year the hard way because I got a freaking like B- in UNIV and it brought my GPA down.
A B- in UNIV?
Okay, listen, I had a really difficult unit teacher. Like, she made us do everything. Like, it wasn't, like, just where you just talked about your feelings. Like, she made us do real work. I had homework in that class, like, every week. I just want to put that out there.
You're probably like one of the only people in the whole world.
I know. And it sucks now because I'm a peer leader. I'm like, guys, this is the easiest A you'll ever get. And I didn't even get an A in uni.
I love that.
So.
What is that? Is that like the intro to college?
Yeah, it's basically just like freshman seminar. And like every professor teaches it differently. And you have some that like go the extra mile, make like a real class. And then some you just literally go in there and like talk about your feelings. Like that's.
My class was so
my professor.
People told us the wackest shit too. They would be like, my dad died. And I'd be like, why are you telling me your class that?
Yeah, like, I'm probably breaking confidentiality, but like doing one-on-ones, they tell you so much stuff. Like one time one of my students like went into like her whole sex life with her girlfriend, and she was like, yeah, my girlfriend hates me because I'm so lazy in bed. And I was just sitting there like, I'm like, this is like 30 minutes.
No, and
mine was like
video.
Mine was like 3 truths and a lie, and people would be like, say one, and then this guy, one of his was that he's like, oh, I'm a liberal, and then that was his lie, and everyone was like, not everyone, but some people were like, oh, good thing you're not a liberal. I'm like, the fuck, like what?
Suddenly I have to go.
But yeah, but like now they're making UNIV like a real thing. Like they have a book and everything.
I had a book. You don't have a book?
Well, we had like the little like what was it like? Wait, what was it called?
$30.
Yeah, but like no, like now it's like an actual UNIV book.
No,
mine was a unit book. It was retarded. Our class was so easy. We had to like go over the chapters and all this stuff. And I was like a new college student, so I was like all studious, and I was like, oh yes, I know all this crap. And like everyone would just sit there and be like, what is like the test, bro? And like she literally gave the study guide for the test, and they were the same test questions as on the test. And she was like, you have to turn this in when you take the test, but you can bring all your notes. So like if you don't bring the actual paper, you could do like study cards. You could have all the answers. But like I'm not telling you to do that, but like you can do that. I was like, what? Did she just tell me to cheat? I was like, what? But it was like so dumb. Oh my gosh.
And my like students, they're always like, what's the point of this class? And I honestly can't ever tell them. So,
that class was during much simpler times.
And like I remember I got into a fight. You guys know who? What's her name? Terry, Brad Williams' wife. Like freshman year, I got into a fight with her because I told her that like the UNIV class was like basically pointless, and like she like went off on me. She was like, I don't feel like it's that, and I was just like, sorry. Cause like I was telling her, like my friend that goes to USF, like their freshman seminar class was specific to their major. So like basically what you learn in that class was just like classes that you should take for your major, like what your GPA should be to get into your like specific program. But ours is like talking about our feelings and like how to be
so smart.
So like I don't.
Mine was about resources, and they're like, hey, come out to the games, and we're like, okay.
Yeah. So like because I went like one time I like snuck into USF with my friend, and like her class was so helpful because like they taught you like internships for your major, like what to look forward to your major. And then I was like, that's not what I'm learning in my freshman seminar class. So
I just learned study tips.
No, I didn't even learn that. I literally hated UNIV so much.
My professor was like, you guys should come over to my house and I'll cook dinner. I was like, what the fuck are you talking about?
Give me an A, I'll do it.
No, he literally was like, yeah, come over.
Oh,
No, he was like very like gay. Like he was like so open about it. And I literally was like, I'm sorry. I'm not coming to your house for dinner. I'm sorry. I will not do that.
I feel like you give me an A, maybe.
You can't not get an A. I don't know how Janelle got a B.
No, because I'm telling you, I had Dr. Judith Slapsky-Barsky.
What?
Something like that. Slapik-Barsky? I don't freaking know. Yeah, Slapik-Barsky. And she literally made it a real class. We had readings. We had to do homework, like multiple critical reflections, multiple presentations. Mm-hmm. And like, I was not trying to do all that. So I did the bare minimum and I got a B-.
I had to make
all right, guys.
He said, all right.
Oh, do you guys want to see my...
Like, I'm out, bro.
He said,
do you guys want to see my beautiful face before I leave?
Oh yes.
My God.
I feel like I was a stranger because like this is the first time I go to school. I haven't been able to make a friend yet. I know we had the group chat, but the mask thing, the social distance thing is like ridiculous. I'm glad to see a few of the faces like I'm glad to see your faces without the mask on, okay? So take your time to look at my beautiful black face, okay? Because I'm about to leave, y'all. All right?
About to leave.
It was a pleasure, guys. All right, see y'all. Where do I leave this thing now? Sorry.
It says leave at the bottom.
Oh, I see it on top.
Yeah.
Mine is actually on top, though. The recording.
Oh, okay.
All right. Good night, y'all.
Good night.
Okay, quick question.
What?
In the group chat, okay, there's a John Lucas. Who is that? Is that him?
No, every time I see that, I have to go and click on his picture. Because I'm like, I've never seen this guy.
Oh, man.
No. Group chat. I thought I don't know who they are. Like, I didn't hear their name on, like, when they're taking attendance. Like, who are they?
I feel like some of them are from, like, the Miami and, like, Fort Myers. So, like, it's just, like, a bunch of us just talking about everything. And, like, we don't know each other.
I'm like, I don't know who these random people are.
I really don't know, like, a lot of the names on there. Like, only some of them are, like, familiar. And I'm not gonna lie, you guys talk a lot in that. Like, my watch goes off all day. And, like, today I had to, like, scroll to see, like, where it actually started. Because I was just like, oh, my goodness.
Wait, I'm like,
it's helpful, though. You guys have
John Lucas picture. It kind of looks like him.
It is him.
Ooh.
Wait, what?
So Friday,
no, it's not.
Monday after class, I was with him because we walked over to the bookstore. And I was with Nadine too. So we spent like a lot more time than I thought we were on that day. And I was like, wait, are you John Lucas? I'm sorry, but I just need to ask. And he was like, yeah, I have a really long name. It's like Jack Saint, John Lucas, Peterson. It's like,
wait, so Jack Saint is John Lucas?
Oh,
I knew it because he asked, not a bad thing, he just asked a lot of questions. So I was like,
I'm like, you sound like
No, I love him. He's the only one I remember in real life because she's always like, Jack Saint.
Yes.
So I only know him. Like everyone else, I'm like, I don't know what any of you look like.
Oh my God, I forgot this was being freaking recorded.
So I was like,
can we cut that out?
No, delete that.
I was like, okay, John Lucas is about to look at this video and like get to the end and be like,
oh, I really forgot. I feel so bad.
It's not a bad thing. I just
how do I do it?
didn't know who that was.
I asked his face, so it's fine. I was like, I'm sorry. Are you John Lucas?
Oh, I'm not the host.
No, I'm the host.
Yeah.
I think suddenly we lost it. Just delete it.
How do I stop it?
We didn't talk about anything important today.
Okay.
Maybe you just hand it back to me. I'll do it.